Turn them off. So we're going to learn sine and cosine, and then we're going to practice sine and cosine only, and then we're going to practice sine, cosine, tangent all mixed up, and you have to recognize when to use which one. Okay, that's the goal. We do have a quiz, so we are working towards being able to take the quiz, make a good grade on it. The quiz covers the Pythagorean theorem, finding the trig ratio, which means like the fraction, and then finding the missing side using sine, cosine, or tangent, okay? So going back to yesterday, page 69, because this paper is, we skipped around. We skipped around and we had intentions of coming back today to do sine and cosine. You can get a highlighter if it bothers you to only have that one highlighted to come highlight that we are now doing sine and cosine. I can throw you a highlighter. The formulas for sine and cosine. Sine is opposite over hypotenuse, and cosine is adjacent over hypotenuse. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. I'm sorry. Okay, so looking at this picture over here, now remember, we're writing the ratio for both angles, so you have to focus your attention from each angle. So this says, what is the sine ratio for angle A? So come to the picture, imagine yourself standing at angle A, so let me erase my arc. It's right here. Imagine yourself standing at angle A. What would be considered opposite of angle A? What side?
Side A.
Side A. And what would be the hypotenuse?
C.
C. Which is why it's helpful to label the hypotenuse, because then it doesn't matter what angle you're at, the hypotenuse is always the hypotenuse. All right, now switch positions. Tell me if I was from angle B, what would the trig ratio be for sine of angle B? So what is opposite of angle B? Little b, and what's the hypotenuse? C. All right, now we're going to practice writing it for cosine. Cosine is adjacent over hypotenuse. So from angle A, what is considered adjacent to angle A? Meaning touching it, but not the hypotenuse. B, right? And then what is considered the hypotenuse? C. Okay, now we're going to switch to angle B. What's adjacent to angle B? Wait a minute. Adjacent? Little a. And then what's the hypotenuse? C. Which brings us to this middle section where this middle section where we're writing the formulas. Sine of an angle is opposite over hypotenuse. Cosine of an angle is adjacent over hypotenuse. And tangent of an angle is opposite over adjacent. Now, I'm not asking you to memorize these, but I am going to teach you an acronym because, one, it's good to practice using acronyms because they do help facilitate the thinking process. When I was in high school, we had to memorize it, but thankfully y'all don't have to memorize it. There was an acronym my teacher taught me, and it looks really goofy, and it sounds even goofier. It's called SOHCAHTOA. SOHCAHTOA. Now, here's why it's SOHCAHTOA. You ready? Sine is opposite over hypotenuse. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. SOHCAHTOA was the acronym that we had to memorize to help us know how to set up the trig functions. Anthony, get off your watch. Okay, now I have good news and bad news. Bad news is you have two new trig functions, sine and cosine. The good news is they are the exact same technique, approach, and steps as yesterday. The only thing that's different is the setup. The formulas are different. It's no longer, yesterday was opposite over adjacent. Our formulas today are either opposite over hypotenuse or adjacent over hypotenuse. Okay? All right, so come down here to this section. We are just writing the trig ratios here. We are reducing them if possible. This is where your calculator and math frac is helpful. Okay? Yes? So I'm going to erase that right there. No, I'm good. All right, we're going to direct our attention to angle A. Might be easier if we just answer the sine of A and the cosine of A before we switch to the other angle. So we're going to focus our attention from this angle, right? Sine of A would be, look at the formula, opposite over hypotenuse. What is the opposite of angle A? 5. What's the hypotenuse? 13. And that will not reduce. Now let's jump to cosine A. Cosine is adjacent over hypotenuse. What is adjacent to angle A? 12. What's the hypotenuse? 13. Very good. So we just knocked out sine A. I'm going to now erase that emphasis and go to angle C. Draw an emphasis on it. And I want you to write the ratio for sine of angle C and cosine of angle C. All right, what'd you get for the ratio of sine C?
12 over 13.
Opposite over hypotenuse, 12 over 13. What about cosine C?
5 over 13.
Very good. All right, everybody move to number 2. Everyone try sine cosine angle W, sine cosine angle X. So in number 2, you should notice the hypotenuse is blank, which means, yeah, I can do my tangent ratios, but I can't do sine and cosine because they both use the hypotenuse. So we've got to use the Pythagorean theorem here to find the hypotenuse. I don't have a lot of room, so I'm going to come over here. Oh, that was terrible. So you had 9, 12, and then we don't know the hypotenuse, which means which letter in the Pythagorean theorem am I looking for? Very good. I'm looking for this one every time it's the hypotenuse. So the other two, you plug them in. Doesn't matter how you plug them in because you get the same thing. So you got 9 squared plus 12 squared equals c squared. Before you can do anything, you need to clean up the stuff that's just numbers. 9 squared plus 12 squared in your calculator is 225. And then you need to remember the goal with the Pythagorean theorem is to have c squared to be just c, which means I need to square root both sides. Square root, and square root of 225 is 15. Now I can set up my trig ratios that I know that this is 15. By the way, just in case, I need you to start noticing this. It makes life easier. 9, 12, 15.
Very far each time.
It's that, remember that Pythagorean triple 3, 4, 5, and then this has just been tripled 3 times 3, 4 times 3, 5 times, it's a 3, 4, 5 triangle. It's just been scale factored by dilation of 3. But anyways, if you can start recognizing those, it does make life easier. If not, no big deal, the Pythagorean theorem works. Alright, now we can set it up. And because every single one of these has a scale factor of GCF of 3, they do reduce. So what is the trig ratio for sine W? So opposite over hypotenuse. What'd you get? And then what does that reduce to? I heard it. I think I heard it. 4/5. Alright, cosine W. So adjacent over hypotenuse would be 9 over 15. And what does that reduce to? 3/5. Alright, switch gears to angle X. Sine of angle X. What would it be? 9 over 15, which reduces to 3/5, and then cosine X, which reduces to 4/5. What do you notice?
There.
Does that happen every time? So far, that is called co-function identities. There's like, think of it as like coexisting. The sine of one angle in a triangle will always be the same answer as the cosine of the other angle. And the reason why is because of their co-function relationship. Look at this picture. The sine of W is opposite over hypotenuse, right? Okay. The cosine of X is adjacent over hypotenuse. They use the exact same sides. Now, granted, they're totally different functions, totally different angles, totally different formulas, but because of the relationship of the triangle, they're going to use the same sides.
So you're telling me I can just figure out the first 3 and then convert them to the other side?
Yes and no. Yes, that works. No, I would not recommend running that route because what if you mess up? Trying to create a shortcut. I would use it as a safety net to check your answers. You know what I mean? I wouldn't rely on it as a shortcut. But that does happen every time. So when we come down here, when I find sine of L, I've also found
Cosine of M.
switch functions, switch angles. I've also found cosine of M. They're going to be the same. When I find cosine L, I will have also found sine M. Now, those only work with the sine and the cosine. You will notice tangent is different. Tangent is just a matter of flipping the fraction. Okay? Alright. So that was just a neat little relationship that I wanted to point out to you that does exist and it's there every time. Now come down here and do sine, cosine L, sine, cosine M. You already know all the sides because we found a missing side yesterday. And we do have common factors, so they will reduce. So reduce them in your calculator. We already did it.
Oh, yeah.
What'd you get for sine L?
30 over 34.
And what does that reduce to? 15 over 17. Okay, now, I already know Anthony's got this. Someone else answer me. What trig function that I have left to find will be the same as sine L? We just talked about it. Try it. You never know. You could totally be right. And even if you're not right, you're trying, which means I can. Okay, is that what y'all both said? I think that's what you said.
Yeah.
Yeah. So cosine M is going to be the exact same answer because of that co-function identity between them. What did you get for the ratio for cosine L?
16 over 34.
Very good. And what does that reduce to?
8 over 17.
And then, so Ryan's got it, Anna's got it, and Anthony's got it. Somebody tell me what trig function will have the same answer as cosine L? Sine M. Very good. Now, that is only because they're in the same picture, okay? That's only because they're in the same picture. So, like if sine M was referring to a different picture, then you don't have that relationship, okay? Different picture, you're going to have to do the problem like normal. All right, go to the back. Obviously, the ones we didn't do yesterday are the ones we need to do today. And the beauty of it is, we have already seen the two scenarios when solving. Either the x is going to be in the top of the fraction, like number 7, or the x is going to be in the bottom of the fraction, like number 10. But you still set it up the same way, and you start to solve it the same way with that elbow arrow. It's just number 10, if the x was in the bottom, you do have one more step to do where you're dividing. Okay, now the biggest question that when I'm teaching this, people say is, I don't know when to use sine and when to use cosine. I've taught you how to know when to use tangent, right? When the hypotenuse is blank. How do you know when to use sine or cosine? Label the picture. Only label the sides that have stuff, then you'll know which one to use. Let's copy our formulas up here at the top so you're not flipping back and forth. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. We are going to label the sides that are in the picture. We are not labeling all three sides because one of the sides is blank, right? So don't label that one because then you will be confused. All right, first, always draw the arrow every time. Draw the arrow. Because this has something here, I'm going to put an H because it's the hypotenuse. Look at number 5. If it was blank, I would write the word blank and remind myself, ooh, this is a tangent problem, right? All right, come back to 4. Draw your arc on the angle they give you. Ask yourself, how's the X that's left to be labeled positioned to the 28-degree angle? There's only 2 choices. It's either opposite or adjacent.
Opposite.
It's opposite. Put an O, look up here. Which trig function uses opposite and hypotenuse? Sine. There you go. Did you say sin?
Yeah.
Yeah. It is a sin to say sin when you're doing trig. It's sine. All right, so we're going to set it up. Here we go. Sine, angle measure, equals fraction bar. It plugs into the fraction using the formula. It's opposite over hypotenuse. X over 19. And then wham bam, thank you ma'am, it is either scenario 1 or scenario 2. In this case, it's scenario 1 because the X is in the top. We're going to cross multiply this over here to the front. You could even just write it right there and mark it out and then go straight to your calculator. You like that better? Yeah. Then you would now make sure your calculator's in degrees. You could have a different calculator from yesterday. Look at the top of the screen. It will say degrees. You need a calculator, please. And when we take this quiz or test, you can't ask me for help on how to type in.
So
19 sine 28. Let's see. Did you get 8.9? If you have green. All right, let's go to number 6. Now, this 21 degrees right here, notice it's on the outside of the triangle, but they have an arrow. If you want, you could mark it out and come in here and write the 21 degrees, but they are saying, hey, that angle measure is 21 degrees. They just didn't have enough room to type it in there. All right, we're going to label our picture. Arrow to the hypotenuse. Emphasize the angle. Ask yourself, how is the other side positioned to the angle I just emphasized? Is it opposite or adjacent? It's adjacent because it's touching it, right? If you traced your pencil on that side, notice I touched where I emphasized the angle. That means adjacent. So which trig function uses adjacent and hypotenuse? Cosine. So let's set it up. Cosine, angle measure, equals fraction bar, adjacent over hypotenuse. Then the first step is to cross multiply this over here to the front. So it's gone from there. And now you can type it in the calculator. Did you get 24.3? Yeah. All right. I need you to do 8, 9, 11, 12, and 13. Once again, don't let the word problems scare you. What is our picture in every one of these problems? It's a right triangle, right? So you will have a right triangle. You just have to figure out how to label the triangle. Some people struggle with the word problems because they're just intimidated by having to like set the picture up, label it, and then they're always worried, I don't know if I did it right, before I try to solve it. Like I said earlier, the picture is the right triangle every time. So you just have to think to yourself, okay, in the real world, if I was doing this scenario, what would it look like? If I took a 12-foot ladder against a house, can you use your arm to show me how it would look? If a 12-foot ladder is leaned against a house, which is exactly what it's saying. I see 3 people. So what part of the right triangle would that be? The hypotenuse. The most common mistake with these little ladder problems is people tend to put the 12, like for the length of the ladder, they tend to put it here. Because I think they just think that like the height right there represents the ladder. This is the ladder, right? It is leaned against the house. It is 12 feet. Now it says if the angle formed by the ladder and the ground, how many angles does a triangle have? 3. And if it's a right triangle, then one of the angles is what measure? 90, which means there's 2 angles left. Imagine this being off the ground, okay? I know it's flat on the paper, but imagine like it's off the ground. You have a house in front of you. You have a ladder leaned against it. The angle 68 is formed by the ladder and the ground. So where would it be? Down here. And then it says, how far from the base of the house? Where's the base of the house? The bottom. So this is the base, right? How far from the base of the house did he place the ladder? So this is the side they're asking for. Because the bottom of the ladder would be here. The bottom of the house would be here. And the distance between would be how far it is. Now, number 13. Ramp is used to load suitcases on an airplane. What's our picture? What do we say is our picture? We have a right triangle, and the ramp is the hypotenuse, right? So you got like suitcases going up to the airplane, right? Like the airplane is right here. Plane. This is the plane. If the cargo door, where's the cargo door? On the side of the plane. So there's a door right here. You need to put a door. Not like that, but you got what I mean. If the cargo door is 7 feet from the ground, where's the 7 go?
Like the center of the hypotenuse. Or no, on the left side.
Thank you. If it says it's 7 feet from the ground, that implies vertical height. and the angle formed by the end of the ramp and the ground is 25. Where does that go?
That's on the B and the hypotenuse.
Would this be 25 here? No.
Down there on the
It says with the ground, so on the bottom. How long is the ramp, which means find which side?
hypotenuse.
The hypotenuse. That says 7 feet, by the way. For some reason, it looks like 7 capital A. That's definitely FT.